This is book section 8.1, so chapter 8, section 1 on ratios and proportions. A ratio is a comparison of two numbers by division, so we usually write this as a fraction. Always reduce if it's possible to. And the terms must be in the same units. You won't see a label on these because it's something like 12 centimeters and 4 centimeters. So they're comparing the same units in these two numbers. A proportion is an equation that compares one ratio to another, so it sets our two ratios, our two fractions, equal. So this is what a proportion looks like. This one says 6 over 8 equals 3 over 4. The extremes are the first and last terms. So these, first, last, these are what we call extremes. And the means are the middle terms. So 3 is a mean and 8 is a mean. So the extremes are the outer extreme terms and the means are in the middle. We're going to talk about a couple of properties. The first one is called the cross product property. This says the product of the means is equal to the products of the extremes. For example, when we usually solve a proportion and we cross multiply, if we start with something such as 1/2 equals 3 over x, we do 1 times x, we're multiplying the extremes, equals 2 times 3, which is 6, we're multiplying the means. So the product of the means is equal to the product of the extremes. We also have one called the reciprocal property. If two ratios are equal, then their reciprocals are also equal. So if A over B equals C over D, then we know that I can do the reciprocal of both of these. And you want to make sure you do the reciprocal of both. Then B over A equals D over C. And if we go back to our cross product property, we can look at the reason. In the first proportion, if we cross multiply, we get that AD equals BC. And the second one, we get BC equals AD. And it's the exact same thing. So as long as you do the reciprocal of both, then this reciprocal product, the reciprocal property is true. So for examples, we'll start with some true-false problems. So true or false, 3/5 equals 6/7. And there's a couple ways you can look at these. You can look at it as an equation that has equivalent fractions. So to go from 3 to 6, we'd multiply by 2. 5 times 2 would give us 10. So those are not equivalent. We can also use the cross product property. 3 times 7 is 21, but 5 times 6 is 30. Those are not equal, so this is false. The next one says 7/11 equals 8/12. Let's check our cross product property. 7 times 12 is 84. 8 times 11 is 88. Those are not equal, so this one is also false. For the two equations, or the two fractions or ratios to really be equal, the cross product property has to work. Let's try this last one. 4 times 9 is 36. 6 times 6 is 36. Those are equal, so that is true. Also, 4/6 reduces to 2/3 if you divide by 2. 6/9 if you divide by 3 also reduces to 2/3. So you can use the reduced form and see if those are the same. The next set of examples says find the missing term. We're going to solve these for the variable. When you cross multiply, you can multiply your extremes or your means first. So we're going to cross one direction. So x times 11 is 11x. When you cross one direction, then we write down our equal sign and you cross the other direction. So my extremes gave me 11x, then we do equals and we multiply the means. 7 times 9 is 63. To solve for x, we're going to divide by 11. So x is 11 goes into 63 5 times without going over. That's 55. 55 to 63 is 8. And I got 5 and 8/11. Let's try the next example. I'm going to multiply my extremes. 3 times a is 3a, equal sign. And multiply my means. 5 times 15 is 75. When we divide by 3, we find that a is 25. Continuing to find the missing term, we have 6 over m equals 7/8. So we're going to cross multiply. And when you're cross multiplying, If any of these parts in your ratios or your fractions ever have a plus or a minus sign, you want to put parentheses around those. We're going to have to distribute when we work with those. So I'm going to multiply my extremes. 6 times 8 is 48 equals, and then we'll multiply our means. M times 7 is 7m. So we'll divide by 7. M equals 7 goes into 48 6 times. That gives us 42. From 42 up to 48 is another 6. So we get 6 and 6/7. Our last cross multiplying example, we're going to solve for C. So I'm going to multiply my extremes. 4 times 25 is 100 equals, and my means, 5 times C is 5C. When we divide by 5, we find that C is 20. You could also look at this last example as equivalent fractions. To go from 5 to a 25 in the denominator, you're going to multiply by 5. We do the same thing to the top. 4 times 5 verifies that C is 20. We can use our proportions and ratios to work through some story problems. Number 1 says the ratio of the measures of 3 angles of a triangle is 2 to 3 to 5. Find the angles. So I have a triangle, and I know that one of my angles is 2 parts, one of my angles is 3 parts, and one of my angles is 5 parts. So we're going to call each part x. So my first angle is 2x, my second one is 3x, and my third one is 5x. I know that 3 angles in a triangle add up to 180, so we're going to use that. 2x plus 3x plus 5x equals 180. So 2 parts, 3 parts, and 5 parts add up to 180 degrees. These are like terms, so we get that 10x equals 180. And when we divide by 10, we find that x is 18. Now, I am not finished. It does ask me to find the angles, so we're going to plug the 18 back in. 2 times 18 would be 36 degrees. 3 times 18 would be 54 degrees. And 5 times 18 would be 90 degrees. I can verify that my answer is correct by checking those. If I add those up, I should get 180. 30 and 50 is 80, plus 10 more is 90, plus another 90 is 180 degrees. Number 2, the ratio of the measures of 2 supplementary angles is 4 to 5. Find the angles. So I know that one of the angles is 4 parts, so 4x. The other one is 5 parts, so 5x. Supplementary means that the angles add up to 180 because the S in supplementary makes the 180. So we're going to add up our 2 angles equal to 180 degrees. 4x plus 5x is 9x, so 9x equals 180. And when we divide by 9, we find that x is 20. Again, we were asked to find the angles, so I'm going to plug back in. Our smaller angle, the one that's 4 parts, is 4 times 20, so it's 80 degrees. The one that's 5 parts is 5 times 20, so it's 100 degrees. Number 3. The perimeter of rectangle ABCD is 60 inches. The ratio of AB to BC is 3 to 2. Find the length and width of the rectangle. And when we talk about these ratios, what's happening is if we take the length of AB and we take the length of BC and we reduce it down by the same number, we get the 3 to 2. So the actual length sides need to be multiplied by what we find for x. So I'm going to start by drawing a picture. I have a rectangle, so I know this is a type of parallelogram. 4 right angles, all the angles are the same. Opposite sides are congruent. And when I label this, I'm going to start with A. So I'm going to pick a corner and start A. And we're either going to go clockwise or counterclockwise. So I'm going to go clockwise. A, B, C, D. Now, the ratio of AB, which is the top of my rectangle, to BC, which is the side, is 3 to 2. So it's 3x and 2x. Now, they give us perimeter. The perimeter is 60 inches. Remember that perimeter is the distance all the way around our rectangle. So I need the length of the bottom side. Since that's the same as the top, it's 3x. And the left side is the same as the right, so it's 2x. So to use perimeter, we're going to add these up and set it equal to 60. So 3x plus 3x, there's 6. 2x plus 2x, there's 4, equals 60 inches. 6x plus 4x is 10x equals 60. And when we divide by 10, we find that x is 6. It wants the length and the width of the rectangle. So my length is 3x. 3 times 6 is 18. So our length up here under the problem is 18 inches. The width is 2 parts. So 2 times 6 is 12. So our width is 2 inches. So the rectangle is 18 inches by 12 inches. Make sure sometimes the problems, instead of saying find the length and width, will say find the dimensions. It's looking for the same thing, the length and width of the rectangle. Number 4, the ratios of the side lengths of triangle DEF to the corresponding side lengths of triangle ABC are 3 to 2. Find the missing lengths using the given picture. So I know that corresponding sides from DEF to ABC are 3 to 2. And that's what it says here. Triangle DEF is similar to triangle ABC. So they're the same shape and not the same size. That ratio is 3 to 2. So I know that a side length in triangle DEF is 3 parts and a side length in triangle ABC is 2 parts. So I want to make sure when I set up these ratios that whatever side is from triangle DEF goes with the 3 parts, and whatever side is from triangle ABC goes with the 2 parts. And anytime the ratios are written like this with a colon, 3 to 2, that's the same thing as 3 over 2. So I'm going to look for the parts that I need to find. It looks as though we need to find X, Y, and Z. So I'm going to go through, and I'm going to start with 2 sides that I have corresponding sides and only one number is missing. For example, if I use, I'm sorry, actually I'm just going to start with X. So let's do X, which is the left side in DEF, over the 6, which is the left side in triangle ABC. Because if I take a side from DEF and compare it to the corresponding side in ABC, the ratio is 3 to 2. I know that DE and AB are corresponding because using this similarity statement, this single kind of a, looks like a tilde, it's the top of a congruence symbol, that by itself up here at the top means similar to. And DE corresponds to AB because they're both the first 2 letters. So we're going to solve by cross multiplying. So I'm going to multiply my extremes. X times 2 is 2x equals 6 times 3 is 18. And if we divide, we find that x is 9. Now I'm going to continue solving without actually using that 9 because I found that, and if it's incorrect and I use it for another problem, it will cause more errors. Let's find y. So EF, which is y, corresponds, EF is the second and third letter, that corresponds to BC, which is 8. And I want to make sure I put the DEF first and the ABC second because that ratio is 3 to 2. So when I multiply my extremes, y times 2 is 2y, and my means, 8 times 3 is 24, and I divide by 2, I find that y is 12. Let's find z. Now again, I need to start on top with the side from DEF that corresponds to where the z is at AC. AC is the first and last letter. DF is the first and last letter. So 6 over z is equal to that 3 over 2 ratio. Multiplying the extremes, 6 times 2 is 12. Multiplying the means, z times 3 is 3z. We're going to divide by 3, and z is 4. Now, if it's in a 3 to 2 ratio, that means the triangle DEF has longer sides. There are more parts than triangle ABC, and all of these should reduce to 3 halves. So if I take the x value 9 and do 9 over 6, dividing by 3, that reduces to 3 halves. The y value 12, 12 over 8, dividing by 4 reduces to 3 halves. And the z value, 6 over 4, dividing by 2, also reduces to 3 halves. So I know I got that problem right. We have another picture, again, triangle DEF. is similar to triangle ABC. They're the same shape, but not the exact same size. One is larger than the other one. That's why the ratio of the sides is 3 to 2, or we could write that 3 over 2. So we're going to start. We'll begin with X. And again, X is in triangle DEF. That's first, so I'm going to put X on top. The side that corresponds to this is the 6 in ABC. And you can double check because sometimes those triangles aren't drawn facing the same direction. One is flipped or reflected. And so the X, side DE, those are the first and second letters. AB is the first and second letters. So I know those are corresponding. And as long as I put DEF to ABC, DEF is on top, ABC is on bottom, that ratio is 3 to 2. Multiplying our extremes, we get 2x equals, multiplying our mean, 6 times 3 is 18. And when we divide, we find that x is 9. To find y, our side y is again, y over 8 equals 3 over 2. So y times 2 is 2y. 8 times 3 is 24. We divide by 2, we said that y was 12. Looking back, we found that z is 4. And again, we can double check those. They should all reduce to 3 over 2. When we come into class, our homework will be on page 461 to 464. We're going to work number 10 through 13, 25 to 47, 54 to 56, and 68 to 72.